large dish-shaped antenna that dominates the spacecraft. Two television cameras are the eyes of the spacecraft. They can be aimed with great precision. These instruments detect the unseen forces that swirl around these distant worlds. September 18th, 1977. Voyager is 7 million miles from Earth. Its cameras turn back to record the blue Earth and crescent moon together in a haunting photograph of our home in the solar system. 14 months later, Voyager 1's cameras transmit the first photographs of Jupiter. February 5th, 1979. From a distance of more than 17 million miles, Jupiter and 3 of its moons are caught in a single frame. At 12 million miles, Jupiter's clouds of gases and ice particles are seen to swirl and twist in strange new patterns invisible from Earth. From a series of more than 4,000 photographs, a time-lapse movie is made that covers 10 Jovian days. The atmosphere is more complex than had been thought. The trajectories of Voyagers 1 and 2 enable the spacecraft to obtain photographs which provide different aspects of each of the 4 Galilean moons. Europa, the size of our moon, resembles a cracked billiard ball, but the complex markings are curiously flat, like stripes painted on the surface. Its icy crust is thought to float on an ocean melted by interior heat. Io is the most spectacular of the Jovian moons. Its vivid, mottled surface with oddly shaped blotches of color mystify the scientists. Surely the strangest object ever seen in our solar system. Ganymede is as large as the planet Mercury. Its dark, ancient terrain is spotted with white impact scars. Adjacent areas are cut by jumbled patterns of grooves and ridges. Callisto is the outermost of the 4 large moons. Every inch of its surface bears the scars of billions of years of cratering. Two scientific discoveries occur during the first flyby of Jupiter. On March 4th, 1979, Voyager 1's cameras photograph a faint ring of particles surrounding Jupiter. Several months later, Voyager 2 photographs the dark side of Jupiter. Backlighting by the sun produces a spectacular view of the ring. It is ribbon-like, 3,600 miles wide. Jupiter now joins Saturn and Uranus to become the 3rd planet known to possess a ring system. A second discovery solves the mysteries of Io's bizarre surface. On March 8, 1979, Voyager 1 takes a remarkable photograph of Io. During a routine study of optical navigation, an engineer sees what at first appears to be a crescent cloud. Scientists soon realize that it can only be a volcanic plume erupting from Io, a huge fountain of molten sulfur, gas, and bits of rock surging upward against the moon's weak gravity. A re-examination of Io photographs reveals other active volcanoes, the first seen beyond Earth. If we could obtain closer views of some of the Galilean moons, each would present a strikingly different surface. Through an artist's rendering, we approach Callisto, the moon most distant from Jupiter. Its surface is saturated with craters dating back to a torrential bombardment period 4 billion years ago. Although this is a dead world, its craters, for the scientist, are a record of the past history of the Jovian system. A great cataclysmic impact basin extends for 1,000 miles, Since Callisto is half water ice, the basin, unable to hold its shape, slowly slumped back into the moon's crust until only traces of the surrounding ridges remain. Ganymede is the largest moon in the solar system. Long parallel ridges and valleys form chaotic crisscrossing patterns created by cracking and shifting of the crust. This grooved terrain borders on regions of ancient surface, vast brown ice fields covered with the remnants of impact craters. Jupiter fills the sky when viewed from the surface of Io, the innermost and smallest of the Galilean moons. Its bizarre colored surface is an ever-changing pattern of the vivid reds and yellows of frozen sulfur. Scattered across the surface are the vents of inactive volcanoes. Many of the calderas are dark in color, filled with lakes of frozen black sulfur. In the distance is an active volcano. It erupts, spewing hot sulfur and gas 200 miles above the surface and falling back in a plume that spreads over a distance of 600 miles. No impact craters are visible on Io because constant eruptions resurface the moon with sulfur and bits of rock. Surface flows that originate in dark volcanic centers spread to fan shapes about 60 miles across, or leave long snake-like patterns. In the polar region are mountains several miles in height and regions that appear to be made of stacked layers of material. These cliffs are created by constant erosion from liquid sulfur compounds escaping from underground and leaving snow-white patches. Jupiter has a huge magnetic field. The field would expand symmetrically in all directions if it were not impacted by the solar wind, a streaming flow of particles from the sun. A bow shock is created where the solar wind meets the magnetic field. Behind the bow shock, the field is warped and turned inward upon itself by the pressure of the wind. It is formed into a long tail that extends 500 million miles to the orbit of Saturn. As Io moves in its orbit around Jupiter, it creates a unique relationship with the planet's magnetic field. In this polar view, Jupiter, spinning on its axis every 10.5 hours, drags its magnetic field and trapped radiation with it. But Io's orbit is slower, 43 hours. As a result, clouds of trapped radiation in the magnetic field sweep past Io and strip away 1 ton of sulfur and oxygen atoms each second into space. These atoms form a torus, a huge ring of electrically charged particles trapped by the magnetic field. An electrical current of 3 million amperes flows along magnetic field lines linking moon and planet. Torus material flattens the magnetic field and flows away from Jupiter to create the current sheet, a thin sheet of charged particles which distorts the field near the magnetic equator. The Voyager scientists had been saturated with surprises at Jupiter, and they approached Saturn with cautious, open minds. In this computer-generated film, Voyager is shown as it arrives at Saturn after a journey from Earth of 4 years and 1 billion miles. The planet's rings are targeted for special study. They present the first of many surprises. In this hypothetical sequence, we may observe the changing appearance of the Saturn rings. All the great classic rings appear to break up into hundreds of small rings, and each of the narrow rings appears to be filled with yet narrower structures. Voyager 2's flight path allows scientists to make a unique study of the rings. A light-sensing instrument is pointed through the rings at the star Delta Scorpii, more than 587 light-years away. The amount of starlight passing through the rings is measured. The experiment finds that what appears to be hundreds of rings are waves in a sheet of icy particles with only a few gaps. The rings hold yet another surprise: dark streaks that orbit with Saturn and then vanish. They are clouds of dust suspended above the ring by some unknown method. Attention is shifted from the rings toward the known moons of Saturn. Mimas is the innermost of the larger Saturn moons, with an enormous crater, 80 miles wide and 6 miles deep. Mimas is thought to be frozen solid. Tethys, a moon scarred by a crater large enough to hold Mimas. And an ancient chasm more than 1,500 miles long. Dione, a moon with bright radiating patterns on one hemisphere and an underlying presence of craters. Rhea shows an icy face to the cameras. Bright streaks are probably fresh ice ejected from beneath its crust. Enceladus, an extremely bright moon that reflects more than 90% of the sunlight that falls on great plains of ice. A closer photograph reveals that it may be a recently active moon with internal heat that melted the surface. Iapetus, the outermost of the larger moons. The dark side contrasts sharply with the lighter trailing hemisphere, an oddity for which there is no present explanation. And Hyperion, an apparent fragment from the shattering of a larger moon, tumbling erratically in its orbit. The most intriguing of Saturn's moons is Titan, larger than the planet Mercury. It is the only moon known to have an atmosphere. Nitrogen and methane gases shroud Titan with dense clouds which our cameras cannot penetrate. The chemistry of this atmosphere is unlike that of any other. If we could descend to the surface of Titan, we might see ice mountains softly eroded by a persistent rain of complex chemicals, and a deep chemical ocean, a strange parody of the oceans of Earth. Titan's atmosphere, like the ancient atmosphere of Earth, contains pre-life chemicals, but is too cold for life to evolve. The moons of Saturn have a direct influence on Saturn's rings. A natural tendency of ring material is to spread both toward and away from the planet. But the moons, in a complex interplay of gravitational forces, shape the rings and define their structure. Years ago, the planets were formed in the gravitational collapse of a great cloud of swirling gas and dust. In that collapse, the gravitational energy of this gas and dust falling inward heated the planets as they formed. Jupiter and Saturn have not yet cooled off. Consequently, both planets give off more energy than they receive from the sun. and this energy is thought to be the heat engine that yields the stormy patterns of their intricate weather systems. An experiment has been performed which demonstrates how these weather systems could work. The major planets can be regarded essentially as rotating fluid spheres, which are heated from within. In the laboratory, this is simulated by a rotating sphere assembly. When instability is induced, long, thin columns are formed in a series of ever larger shells or layers. The layers create wind flows moving at different speeds, and the tips of the columns form the familiar bands of Jupiter's clouds. If this is what happens, and there are competing theories, it could change our understanding of weather systems on these giant planets. Jupiter and Saturn have dozens of storm systems. On Jupiter, the white opals are smaller versions of the Great Red Spot. The red spot is larger than several Earths and rotates in 6 days. This violent storm has existed for at least 300 years. Its center is quiet, but the outer rim seizes clouds and smaller storms and whips them around the edge of the spot. A series of blue filter photographs assembled to form a movie of the red spot enabled scientists for the first time in centuries of observation to study the storm's motion in detail. Saturn's atmosphere appears similar to Jupiter's, with alternating dark belts and bright zones, alive with eddies that swirl and dissipate their energy into atmospheric circulation. It is the summer of 1981. As Voyager 2 flies behind Saturn out of sight of the tracking stations on Earth for 2.5 hours, the movable camera platform jams and stops. When the spacecraft appears from behind Saturn, it is programmed to again transmit photographs. But in place of images, only blank frames are displayed on the monitors. The platform is obviously not pointed where it should be.
It's not there.
All the instruments on the platform are put into a standby mode, and project engineers begin to analyze the problem.
Thing was supposed to scan.
2 days later, engineers find that with care, the platform can again be commanded to move. Despite the fact that Voyager is 1 billion miles from Earth, engineers are able to pinpoint its problem and successfully restore the platform to use. An image reappears on the monitor screen, and the final photographs of Saturn and its rings are sent to Earth.
Ellis has drawn what you should be seeing.
The frame's upside down.
August 1981. Voyager 2 recedes from Saturn on its journey to Uranus and beyond. The recent discovery of 9 rings encircling Uranus and its 5 known moons hold the promise of fresh discoveries. And in 4 more years, Voyager 2 will reach that planet. Years later, it will reach the 8th planet, Neptune, and its great moon, Triton. Meanwhile, Voyager 1 will continue its flight, searching for the unknown edge of the influence of the sun, where interstellar space begins and our sun is just another star.